Thank you. Let me switch over live so you can see me. Hello, everyone. My name is Kane Peterson. I actually am on the professional services side at NewTek, and I'm one of the main instructors at NewTek University. So I'm going to take you through a little more of a, I guess you could say, theoretical aspect of NDI, just talking about how the protocol works and some aspects of it here. Actually, many of these slides are out of, I do have a NewTek University class on NDI, so I've taken a very small sample because there's like, 6+ hours of content in that class. Obviously, we don't have 6 hours to spend here, but try to concise down a very, small version of what are the core pieces about NDI to know about. So let me take you through, and then of course after we're all done and Jeremy talks, we can try to answer questions. So NDI, if you're not familiar, stands for Network Device Interface. So that is what the letters stand for. And I'm going to kind of go from the standpoint of, let's pretend you don't know much about NDI at all. You've heard about it, right? It's a video IP protocol, but beyond that, you don't, it's like, I've never used it. So that's kind of the starting point here. So the first question usually comes up is like, well, how would you describe NDI? And I think in a very short description is that it's a royalty-free software technology for sending high quality, low latency video over standard Ethernet networks. And there's actually 4 key pieces in that one sentence. So royalty-free software, NewTek does not charge anybody to get access to the software development kit. They can include it in the software products they're building. They can sell them, distribute them. We do not, there's kind of no strings attached effectively there. We're talking about software when we say that. There is a hardware level development kit as well, or the embedded development kit as it's called. That one there is licensing for. So in case you've looked into it, I want you to come back and say, hey, there is some. But from a software standpoint, if you're making a computer application, it's free. It's high quality and it's low latency. So we're talking about video that looks and performs like SDI video. It is compressed. We'll talk about compression in just a little bit, but the compression is high quality compression. Nobody's going to look at this video and be like, what happened? What did you do to it? It's going to look like video they're used to looking at. Low latency, typically for most cases, we're talking 1 frame of video or less for transmission time. So you could run this alongside SDI and people are not going to see the difference of what's going on. And by standard Ethernet networks, we are talking about 1 gig Ethernet being the target here. Now, there are cases that it can run on less, that we can even make it run over Wi-Fi or less than gigabit, and certainly can take advantage of better than gigabit, right? 10 gig and stuff like that. But 1 gig is really all you need to make it work in most situations. And we have lots of people out there producing entire events, and all they have is 1 gig networking. Now, part of this is that, what we're looking for is, this is not a cable replacement, right? The goal of this is not to just say, let's replace our SDI cables with RJ45, Cat5, Cat6 cables. It's the enhancements it brings. It's what else gets added to your workflow by going this route. And NDI is not new, really. We're actually on version 4.5. It's been out for many years at this point, and we've already got thousands of companies that have downloaded the software development kit. There are already hundreds of products available in the market, and if you look at over all the years and everybody use it, there's been used by millions of people, because we're talking people both, gamers running in their basement, right, producing streams you watch on Twitch, all the way up to, if you name a 3-letter broadcast company in the United States, using it. And believe me, they're all using it. So there's a lot of range that this protocol goes from, literally the lowest of the low end to the highest of the high end that has seen use. Now, one of the questions might be, why why do we want to do this? SDI has served us well for a long time. So what is the point? Why should we look at changing this out or looking at this as a future way? And Carl already covered on a lot, but I'm going to cover a few extras here. And this is not to say that these are the only reasons. These are just some reasons. And there's other reasons I don't have in this list. There's reasons that might apply to you that don't apply to somebody else. So just, there's just some of the reasons. A big one is flexibility. A lot of stuff is done on computers now, right? We're using PCs and Macs and Linux machines to deal with video, and you otherwise need to get I/O interfaces for them, and then what kind of I/O interface determines how many channels of video it can work with, and what video formats it can bring in and bring out. With this, I don't need any of that. I plug it into the network, and all of a sudden, this computer can now deal with multiple channels of video in and out simultaneously. So the ability to just use computers, buildings are already wired for networking, so you don't have to be running network cables around or video cables around, right? The network cables are already in place in a lot of facilities, make it very flexible to start working with it. It's extensible, right? We can make it do new stuff as time goes on. So like from when NDI 1.0 to where NDI 4.5 has come out, we've added new features and new functionalities to it with new support for new compression protocols, PTZ support, the ability for remote sources. All sorts of things have been added to it over the years. And that's not to stop. It will continue on, but it's certainly much easier to extend an IP protocol with new functionality in the future based upon needs and capabilities that clients and workflows require. The cost. Now, I know some people might say, well, an NDI piece of equipment might cost more than a traditional piece of equipment. But if you look at the overall workflow, there's actually advantages that can come into place and costs can be achieved. Network gear is typically less expensive than traditional, proprietary video gear. A network switch is orders of magnitude cheaper than a video router would be, and in general, also much more flexible at the same time. Network cabling is also generally less expensive. So when you start looking at the big picture of everything, cost can be achieved for a large-scale facility because you can start taking advantage of all of this off-the-shelf technology and stuff that you might already have in place as well that you don't have to necessarily go out and buy and start building up your equipment. Compatibility, it's not just NDI. I mean, really the key part here is that its IP is the underlying technology behind all of this. And we can run other things across it besides NDI. We can run Dante audio, AES-67, other protocols, HTTP for control and other data formats and stuff. So all of this can be, shared on that same infrastructure. So again, allowing it to be less expensive because you don't have to be running more cables and more type of infrastructure to support these other types of things. And compatibility can be achieved as well. As new systems come out, we can still have them be backwards compatible or even have software upgrades that can take older systems and make them do newer things. So there's a lot of advantages from that standpoint. And then time is another aspect. Setting up a network, right? It's one cable, can run multiple channels of video. As I mentioned, buildings can already have networking in place, so you might not even have to run any cable to some degree. So there's a lot of things, even on a time standpoint, that can be saved by going with an IP infrastructure. Okay, so let's take a look at NDI. What does NDI itself offer as a protocol? So we've tried to build it as forward-thinking as possible. So it is resolution independent, frame rate independent, aspect ratio independent, number of audio channels independent, sample rate independent. All of these things can be defined. Now, I will admit most applications and workflows are probably going to target a traditional video format because that's what we need to work with. But NDI itself is not limited to any of those things. You could have, there are people in Japan doing 8K with it already. You can do weird aspect ratios and all sorts of stuff. So it is set for what we need to do now, but also designed to handle stuff in the future as new things come out. It supports alpha channels. So alpha channels automatically built into the protocol. It becomes something you don't even have to think about. It's just there when you need it. It supports both video and RGB color space. It supports the ability to translate between them, and it can do that at up to 16 bits per pixel. So it's accurate color translation. Applications can be designed that can go up to 16 bits per pixel, so HDR can be handled by it today. That does mean, though, that the applications that you're building have to understand HDR as well. So it's not just that, hey, NDI supports HDR, everything does. It is that I have the ability to transport it, but obviously if I need to color correct it or do other things, the application on the other end needs to understand what this information means and how to process it. But again, NDI is ready to handle it today. Beyond traditional video, audio type information and alpha channel, right, we can also put commands in NDI, metadata, time code, tally information, PTZ, even custom data can be included. So again, all sorts of other information can be transported by it as well. So it's not just video and audio, it's virtually everything of your workflow could be encapsulated inside the NDI protocol. And it is supported virtually on everything. So there are the software development kit includes support for Windows, Macintosh, Linux. There's stuff for ARM-based development and also hardware development using FPGA for like embedded type devices. And they're all cross-compatible with each other, so all of this stuff can work side by side. All right. So NDI is actually available in kind of two major variants or formats. So you maybe, if you've looked into it, have heard a little bit about these. There is NDI, which we call high bandwidth NDI. This is the predominant method that is used. If it's a software application or an FPGA device, it's using this type of NDI. But there's also a version of NDI called NDI HX. And the HX actually stands for high efficiency. That's what the HX is designating. And this is typically used by hardware-only devices, although that's not exactly the restriction anymore, but certainly when it came out, it was. And the whole idea with this was that there were already devices on the market, PTZ cameras being a big one, but not the only thing, that had onboard compression circuitry, and we basically added this in so that we could adapt those existing devices to start spitting out a flavor, right, this NDI HX flavor of signal, so that you could take devices that were already in the field, like Panasonic and PTZ Optics and other companies, and basically install some new firmware on those devices, and all of a sudden they could start talking NDI. Now, to talk about these a little more in depth, NDI, the high bandwidth variant of NDI, uses a iframe compression structure. This means that every frame of video is compressed on its own. This allows for very low latency because of that, right? We can just compress each frame of video and immediately send it on. The compression structure uses what's called a DCT, or discrete cosine transform type compression. This is similar to the same kind of compression that you find in ProRes or DNx HD. So if you've worked with those protocols, and I'm sure almost everybody has, that's basically what NDI uses. It's our own variant tweak of it, but essentially that's when you get down to it, what is being used to compress the data structure down. The bandwidth used by NDI is set by your frame rate and frame size. This is not something that's a user dialable in adjustment. You basically say, I want to send a video frame that's of these parameters, and then NDI will say, well, this is how much bandwidth it will need to be. And I'll show you in a second here what some of those data rates typically are. Because this is an iframe only, we can get compression down to a frame or less. So in software applications, it's typically a frame. Maybe depends on, I guess, if we're talking a field, fielding or frames, right? If we're talking in fields, it actually works at fields. In hardware encoding, we can do it in less than a frame. We can actually start compressing at lines of resolution. So we've got converter boxes out there made by us and other companies like Magewell and BirdDog, where you can show an SDI and an NDI connection between devices, and it's the same frame of video showing up on the other end. And high bandwidth NDI, the target really for this is 1 gigabit networking, right? It's not designed to really run on less than that. There are some limited cases where you can make it work, but really for the most part, 1 gigabit is what you would use with this. here are what some of the, for major video formats that we're used to, here are what some of the data rates are that are used by NDI. Now, these are targets, right? NDI does use a variable bit rate compression, so it's not like, exclusively this number. It can vary around, but typically this is what you would probably find realistic values being used. But again, if you send it a very simple picture, it will compress down more if it can. Now, NDI-HX, which I mentioned, is a different flavor of NDI, and there's actually now two different types of NDI-HX. There's NDI-HX1. This uses an H.264 style long gop compression. It's much lower bandwidth, so about 15 megabits. Because of this long gop compression, the latency is a few frames, so it's a little bit latency. That's the trade-off, right? It's a little bit of latency for more compression, but because of this, it also works better in bandwidth-constricted connections. So like Wi-Fi, less than gigabit, or even WAN style connections can benefit because we're not trying to pass as much data through. There's also a newer variant of NDI-HX called NDI-HX version 2. This just came out last year, was when it was first supported. This is a tighter integration. So as I mentioned, NDI-HX version 1 was really like, we took existing devices and we kind of, made new firmware to make them work. There was only so far you could go with that, right? Because these were devices that were already in the market. It's not like we could completely reprogram them. We could only program them to like, so much. So with NDI-HX version 2, this is basically if you're making a new product and now you have the ability to, program everything about it because you're developing it, this is what you would use. And this allows for tighter integration with NDI. It supports more of the NDI functionality like groups and discovery server and stuff like that. And in fact, it is even possible for a software application to support NDI-HX version 2 if they wanted that higher compression, algorithm to be used. Again, with the trade-off being a little bit of latency, but this is the other variant that's out there. Okay, now that we've talked about the types of NDI, let's talk quickly about how does NDI talk on your network, right? How do devices find each other? How does this process operate? So NDI has a built-in discovery and registration mechanism built into the system, and then it also, once this is handled, it then also sends the transmission. So it's really a complete protocol in the sense that it's, finding devices, it's registering who's out on your network, and handling the communication. So it's handling the whole aspect of everything you need in here. So let's imagine that this circle you're looking at is a computer network, right? It's just, thought, version of it. It's not a Tolkien ring network. I don't want you to think I'm talking about Tolkien ring here. And imagine we've got an NDI device on it, right? Doesn't matter what it is. It's just some NDI device. And we have, let's just say, our video switcher. All right. This could be one of many devices on the network, but we're just going to focus on these two right now. So you put these devices on the network, you turn them on, you start up their software, and they will send out a broadcast. And this broadcast will say, here I am, here's the sources I have available, and all the other systems on the network will pick up this broadcast, and it will store this information in its list of NDI devices that are available, right? It will say, okay, I know who you are. I know what you got available. I know where you are in the network, right? Your IP address and all this kind of stuff. And so now the user goes in and they select off that list. They say, I want to use this source, right? They pick it off the list. So when you do that, then NDI will form by default, a unicast type network connection, and, data will start to flow across that connection. Now, NDI also has the ability to work at two different video qualities. There is a proxy low bandwidth version, and then there's a mezzanine high bandwidth version. And this is something that, depending upon the applications, either one or the other could be asked for, or sometimes it's a user selectable thing. Sometimes it's just the way the application works. So it's a little bit, it's there. I just wanted to let you know they both exist. So in our case here, a low bandwidth version of video is sent across where this can be used to fill like a multi-view window, right? We now can see that there's video coming in from that source device. Now, in the case of our video switcher, we go and put this source on program output. Our program could then say, let's switch to we need the high bandwidth, right? We want to have full quality, high quality looking video, not just the low quality stuff. And it can immediately switch that video to the high quality bandwidth. And at that point, we're in our example here, 1080p 60, it's pushing about 130 megabits of data across the network from that source in there. Now, if that other device was like a PTZ camera, right, that was NDI HX, that same thing would be about 15 megabits of data, right? It depends on exactly how you have it set, but that's probably a realistic number. And on that same connection that's flowing video one way, we can also be flowing back information like PTZ control and tally information, so that, again, each connection is bidirectional. So it's not just that data is flowing in one direction, but we can be returning data the other direction, so that, it's not, we can have stuff going back and forth between these two devices in here. Now, we've just looked at it for one connection, but obviously the same idea can just be expanded up, where I can have multiple devices coming into a single device, and of course that device could be sending signals back out somewhere else. We can also share a single output among multiple destinations. So like this PTZ camera, maybe I had 3 different people that all needed to see the output of that camera. I could do that as well. So the nice thing here is that when you start to think about it, your network, it becomes like the network video router, right, that we're used to, except it's just your computer network becomes that. And all of a sudden now, video can just be pulled up anywhere on any other device on the network that has the ability to see it and has a proper NDI software installed. It's maybe one of those things that you can see it on a slide, but once you have experienced it in practice, it is a game-changing aspect. All of a sudden, it's not like, how do I get video in here? It's just, open this tool, there's the video, I see it. It just becomes freeing in the sense of how video can work compared to what we're used to. So it's pretty amazing from that standpoint. Now, we mentioned that NDI is unicast, and that is the default method of transmission that is used. What that means is that every channel of video that's sent from a device uses the same amount of bandwidth again. So if 3 people were going to view an NDI source, it would use 3 times the amount of bandwidth. The nice thing with unicast, though, it's very easy to set up and work with, so that's kind of why we go with it by default. It is possible. NDI does support multicast capabilities. This would allow you to save that bandwidth where you don't have to send it out like 3 times. You could send out one signal that gets shared out by the switch multiple times. So you could now, I had 20 people that all wanted to view a source. Could I make that happen? Yes, with multicast you could. There are some requirements, though, to make multicast operate correctly, which is why it is not the default. But if you put the right pieces in place, it can be set up and done. Some other aspects of NDI just to talk about. NDI, starting with version 4, has a recording capability that's built into it. We call it native NDI recording. This allows you to take the NDI data stream, write it to disk as a QuickTime file with an NDI sidecar file for any of the additional information that QuickTime can't store. And the advantage of this is that there's no recompression. So the exact same data rate bit stream of NDI can get saved to disk without degrading the footage at all. And because the hard part, which is the encoding, has been done on the source device, right, on the recording device, there's almost no CPU overhead involved. It just takes that data and writes it to disk, which makes it very simple. There are codecs available for all sorts of applications to be able to read and work with these files. We also have a tool called NDI Access Manager that allows you to go in and define your NDI groups and how things are shared. So this is something you can look at. This is what that software looks like on there. And then just a few last things to talk about. NDI does not have to be an island. You can have different, what do I want to say here? Different applications that can exchange NDI between each other. So we have a product that will adapt between the SMPTE 2110 and NDI workflows. So if you already have that or you're looking to combine these together, that's certainly possible. And beyond that, NDI can also be adapted with virtually any other IP format available. So there are workflows out there to adapt it to Dante and AES67 and SRT and RTSP. So you name it, you have other types of protocols and formats you're working with. It's undoubtedly you could make NDI fit into that workflow as well. The last thing I want to leave you with is let's say you want to experiment with NDI more. You're like, this all sounds great, but how can I get my hands on it and try some stuff? Now, Jeremy's going to show some of these in a minute, but I just want to kind of talk about them really quick. There are a bunch of free applications that you can download, most of them in a package called NDI Tools. And these are applications for generating and viewing and controlling NDI streams. So you can go and get these programs, install them on your computer. They're available for both Windows and Macintosh. Most of them, all of them on Windows, most of them, but not quite all of them on Macintosh. And then you could start trying this out on your network and seeing how NDI flows and works and, you know, the kind of things you can do with it.